1.5 times 2 times 10 raised to power 4 will give us 3 times 10 raised to power 4, which equals to minus 450 volts velocity. Then doing our multiplication, we have 1,350,000 minus 30,000, which is equals to 450 velocity. Then doing our subtraction, we have 1,320,000 is equals to 450 velocity. Making our velocity the subject of the formula, we have that the velocity will now be 2,933.33 meters per second. Example 8. Find the momentum of the body in which of the following: A. Mass 2 kg, velocity 0.5 meters per second. B. Mass 80 kg, velocity 15 meters per second. C. Mass 30 kg, velocity 72 km per hour. Solution: A. Momentum is equals to mass times velocity. Our mass is 2 and our velocity is 0.5. If you multiply the two, we get 1 Newton seconds. B. Momentum is mass times velocity. The mass is in gram. To convert it to kilogram, we divide it by 1000 to give us 0.08 kilogram. Then momentum m is equals to mass 0.08 times velocity 15, which give us 1.2 Newton seconds. C. Momentum is equals to mass times velocity, and mass is equals to 30 kg, but the velocity is in kilometer per hour. To convert it to meters per second, we times 72 by 1000 and divide by 60 times 60, that is 60 minutes and 60 seconds, to give us 20 minutes meters per second. Then our momentum is now equal to mass times velocity. Our mass is 30 times, but our velocity is 20, which gives us 600 Newton seconds. Example 19. A trolley railway track, mass is 0.3 kg, traveling at 2 meters per second, collide with another stationary truck, mass of 0.25 kg, and they couple together. Find the common speed after impact and the impulse between them. Solution: we have that the mass of the train is 0.3 kg, moving at a speed of 2 meters per second, and it collides with a stationary train of mass 0.25, and two of them have, we now get a common velocity of 1.09 meters per second. Do you think you can pause and see if you can get this as the common velocity? If not, okay, let's show you how. Giving positive to the direction of force, m1 v1, that is mass of the moving train plus times velocity of the moving train plus mass of the stationary train times velocity of the stationary train is equals to mass of the sum of mass of the two trains combined together times their common velocity. Then we substitute the value. We have that the mass of the moving train is 2, and that its velocity is 2 meters per second, plus the mass of the stationary body is 0.25, and the velocity is 0, which will now give us the mass of the two objects is 0.55. Then we make our multiplications and additions. We get 0.6 equal to 0.55 velocity. Then if we make velocity the subject of the formula, we now have our velocity to be 1.09 meters per second. I hope we are now clear the web. Now looking, we are also asked to get the impulse between the two, which one gained and which one lost the impulse. But you know that from the formula of momentum, Ft is equal to mv, that is mass times final velocity minus mass times initial velocity. Then the mass of the moving train is 0.3 times the velocity, which is 2, plus the mass of the stationary train is 0.25 times 0 minus the mass of the train, which is moving train, which is 0.303 times the initial velocity, which is 2. After we did our computation, we have 0.005 meters per second. But for the mass of the stationary body, we have that 2, which is the mass of the moving body, times 0.3 plus 0.25, which is the mass of the stationary body, times 0 minus 0.05, that is the mass of the both body combined together times their common velocity, which you now have 0.6 minus 20.3052. If you did subtraction, we have minus 0.2948 Newton seconds. Therefore, there is loss of momentum after collision, but there is a gain in momentum before collision. Temperature measurements. Temperature is the degree of hotness of a body. Temperature scale. Absolute temperature scale. The ice point is 273 Kelvin and the steam point is 373 Kelvin. Celsius scale. The ice point is 0 degrees centigrade and the steam point is 100 degrees centigrade. Fahrenheit scale. The ice point is 32 Fahrenheit and the steam point is 212 Fahrenheit. Heat. It is a form of energy that can increase the temperature of a body. Scale used in measuring the temperature change. 1. Centigrade scale. 2. Fahrenheit scale. 3. Raman scale. 4. Absolute scale.